Hello everyone, this is Magda from MVApp, and today I'm going to show you how to perform ANOVA or other non-parametric tests to test the differences between your samples. First of all, we need to make sure that your data is properly uploaded. For this analysis, you don't need sample information or time information, but of course, if you want to compare different time points, I would encourage you to select that. Just make sure that your data is uploaded as you want it to be, and then we can continue in going into Data Exploration tab. So for ANOVA, ANOVA is a parametric test, and you need to make sure that your data is having a normal distribution and that the variance between the samples that you actually want to compare is equal. If that's not the case, don't worry, we also integrated some of the non-parametric tests. But if you want to make sure that the ANOVA results are valid, those two assumptions need to be met. So let's go to Testing Significant Difference tab. And in the graph, you can see which of the two samples are being compared for significant difference between them. In here, you have an ANOVA report telling you whether the ANOVA is, the outcome is significant or not. Right now we're comparing different treatments, but you can of course change that. You can compare, for example, different genotypes. So of course genotypes, the ANOVA, whether the effect of the genotype is significant is a great news, because it is, but in the case of more than two samples, it doesn't really solve anything, because we would like to know which of those genotypes are exactly different from each other. So if you scroll down, you have an output with all of the significant groups with two key pairwise comparisons. So if the sample is containing the same letter, for example those two or those three, they are not significantly different, but they are significantly different from the groups that are containing non-shared letters. If you wish to perform a non-parametric test, we also integrated that, so that's a Kruskal-Wallis, and here you've got the results of that, and then the pairwise comparison is tested using pairwise Wilcoxon, or also known as Mann-Whitney test. If you would like to subdivide your sample, so you would like to know the difference not only between your accessions but also between your treatment, you can subdivide your samples, and then that appears like that. But if you also would like to further subset it and test it per individual day, you can click in here and then check which subset would you like to inspect. Alright, this is it for today. Thank you very much for listening, and I hope you're having a lot of fun using our MVApp tool for your data analysis. Bye bye!